All right, guys. Oh, there's a whole bag of calculators up there, buddy. All right, let me catch up to you guys here. Let me see if I can do this. A4, 13, 50, and 17, 126. Thank you. All right. Here we go, guys. So, anytime I give you a table, triple check that number because that's going to mess everything up if it's wrong. All right. So, this mistake is really easy to make, and even after I point it out, it's still just our brain just doesn't really get probability. So don't feel too bad about this. We're not hardwired for this. Doesn't mean we can't learn it. But this will not be 1 out of 126. What question would I ask to make the probability 1 out of 126? And have to say, given it's a Grossmont student, what's the probability that I pick you, right? It has to be very specific. There's only one person that matches what I'm looking for, so my chances are low, right? So that's not what's happening. Out of everybody, out of 176 people, because I didn't tell you anything about the person, so it could be any of those 176 people, how many chances do I have for it to be a Grossmont student? 126 chances, right? So if I buy 2 lottery tickets, my chances to win should double. It shouldn't still be 1 out of whatever just because I have one winning number. I have 2 chances to get that winning number. Does that make sense? So it's all about what are the chances that you have to match what you're looking for. 126 out of 176. And then when you divide that, what's it come out to be? 21.75. 27.5. Okay, so 71.5% just about? Yeah. Roughly. All right. Is a business major. Same idea. Out of 176 still. What's the only problem up here that's going to have that does not have 176 on the bottom? Yeah, the only one is E. That's the only one that you know something about, the student, so you can throw some people out. Every other one could have been any of them. So out of 176, how many match what I'm looking for? 92. If you divide that, what do you get? 52 point something? Okay. Of course, I'm going against what I asked you to do. Right? 4 places. But we'll get there. Computer science major or Grossmont attendee. So I have to include both of those. So one way I can do this is to say I've got to take all the computer science major. There's 73 of those. I have to add in all the Grossmont people. There's 126 of those. But if I do that, I've counted these people twice. That's not fair. So I got to subtract 62 off. And in fact, if I didn't subtract 62 off, what is 73 plus 126?
199.
199 out of 176. That is bigger than 1. That is a red flag. Right? That don't stop there. Don't just do that because that'll drive me a little crazy. You should know that probably can't come out bigger than 1. It can't come out bigger than 100%. So if you can't figure out why, at least go, I don't know why, but I know it shouldn't be this. And I'll go, okay, I feel better. And maybe I won't take off as many points. Out of 176, so it's like 77.84. 84? Okay. I can deal with that. Cool. How are we doing so far? You guys understand how this works? I saw way too many 1 out of something. But that normally is not the way it's going to work unless you're saying, I only want that one person. The person who hit my car this morning. You know, hopefully that's just 1. Or 0, thank God. Now this one, the funny thing is, let me see if I can manage to get you guys to realize something. So I can just get the answer directly. I think I said this before. This is new to math people. Formulas have got to be very general. So in specific cases, you can have an easier way to do the problem. And we've seen this before in math. We've seen this before, but probability is where it really comes out. I can just count what the hell's going on. And to make a probability, on the top goes the number of people that match what I'm looking for. Well, how many people match what I'm looking for? 2. There's only 2 people that are math majors and Cuyamaca students. Out of how many total people? And then I'm done, right? But just to show you, please, dear God, in fact, put your pencils down for a moment. Don't even write this down. But the formula does still work. The probability math and Cuyamaca would be the probability they're a math major times the probability they're a Cuyamaca student given their math major. That is the formula, right? I wrote it a little better there. That's the formula. I've got to multiply those together, but it's got to be the given. What people always do is they multiply math times Cuyamaca, and that you're assuming they're independent. You get some funky-ass answer. So watch this. What's probably their math student? No. What's probably their math student? I'm sorry, 11, no, I was thinking ahead. Now, what's probably their Cuyamaca given a math student? So what's going to be on the bottom? 11. And on the top is going to be, out of those 11, how many Cuyamaca students? Look what happens. The 11s, and you get 2 out of 176. The same damn thing we got quicker over there. So if you apply the formula correctly, it has to work. It's just that in specific situations, there are easier ways to get the answer. Okay, maybe. Like, for example, up here, I don't know if anybody just didn't subtract because you just added smart in the first place. You could do, for this problem, you can say, I need all 126 of these people, plus these 11 computer science people I haven't added yet. And either way you do it, you get to the same answer, of course. You can just be more specific, quicker in that situation. Okay. Let's see if I can do this here. So what about part E? What goes on the bottom? Yeah, because I'm given they're a computer science major, so I know only something out of 73 people could have happened. Out of those 73, how many are Grossmont students? 62. And when you divide those, you get 0.8493. I like it. Or let's say 84.93%. Kick ass. I will always do this because I am trying to be nice. I'm going to ask you this question. That's not the nice part. You guys don't like it. That's not nice. But I'm going to ask this question. You've already done the work that you need. Here's the probability that they attend Grossmont. Does that probability change if I tell you they're a computer science major? It was 71.5. If I tell you they're a computer science major, now what's the probability they're a Grossmont student? Almost 85%, right? Do you guys see that? How do you check to see if two things are independent? You see, given that one thing happened, does the probability of the other thing change? So you've got to compare Grossmont given computer to what Grossmont used to be. And if I tell you they're a computer science major, the Grossmont students only skyrocketed, right? Went from 71.5 to 85% almost. Maybe not. I don't know. You cannot, let me see if this sinks in this time. I say this every time, and I always get like half the class gives me a paragraph. You cannot write a paragraph on part F explaining why something. Well, it's obvious that if you're this, then no, you got to do math. That's the only way you can prove anything about part F. To be independent, it's a mathematical definition. You got to check to see, does the probability A given B, does it change from what probability A used to be? That's all you got to do. You got to love it when you have the letter B and the word B in the same sentence. But okay, hopefully it has followed. So I look at what Grossmont used to be, and then I look at what it becomes once I tell you something about the student, and it changed. So they are dependent. Probability of Grossmont given computer science is not equal to probability of Grossmont. 71.5% does not equal 84.93%. Bam! Maybe. Don't say, well, there are computer science majors at Cuyamaca. No, that has nothing to do with this. Nothing. Okay, maybe. All right, so how are we doing with part 1? Any lingering questions on part 1?
So yeah, we could find out if they were independent. Thanks.
Cool.
We can find out if they're independent if those two probabilities equal each other.
Exactly. If I think I still have it up here somewhere. No, it's gone. Yeah, here. They're independent if this probability equals that probability. So in this problem, it's Grossmont given computer science. Does that equal probability of Grossmont? They didn't. So they're dependent. One thing happened, and it changed the chances that the other thing would happen. Yes?
So for like A through F, could you like round your percentages up if you also put the decimal point value?
Yeah, you know, on a test, if I say give your answers as decimals to 4 places, then if you have that, I almost don't care what you do next,
Okay.
as long as it's true. So this one, 0.8493, you can say roughly 85%.
Okay.
That's awesome. Kick ass. How we doing? All right. Number 2, this is my little twist on the poker chips. And some election years, you feel like they are just freaking poker chips. All right, that's equally bad that happened. Or has anybody voted yet? Have you guys ever voted before? Yes? Yes. All right, good. Anybody voting for the first time maybe coming up soon? All right, look at that. Making me feel really freaking old, isn't it? I was back in the time of the hanging Chad. 2000. What? It says, look that up. Google it. Hanging Chads. And just waiting forever. Oh, sorry. So in this case, instead of being in a bag, I've decided to put these people in a haunted house for some reason. That doesn't really come into play. If we pick one person at random from the house to save them, it's like the reverse of Big Brother, I guess. What's the probability that person is a Democrat? Yeah, so the first thing you got to do is, how many are there? 21. So there's 7 Democrats out of 21, which becomes, 33%. All right, good. I like it. Not too bad. And the person is a Republican.
12 out of 21.
Yeah, 12 Republicans out of 21, which becomes
57.1%.
57.1%, blah, blah, blah. Okay, cool. So I wanted to start you off nice. Now we're going to take 2 people. So if I'm going to take 2 people, I'm going to put 2 little empty spots here. A little hangman game. And it's with replacement, so the probabilities will not change. What's probably the first one is an independent. 2 out of 21. And then I put that person back in the house. What's probably the next one is a Republican.
12 out of 21.
Look at that. In stereo. And whatever the hell that is.
5.4.
Who to what?
5.4.
5.4%, okay. We select 2 Democrats. So what's probably the first one is a Democrat?
7 out of 21.
7 out of 21. Put that person back in the house. The next one is a Democrat.
7 out of 21.
Kick ass. So that's 0.1111.
Yeah.
I got to show off my one skill in this world. So 11.1 repeating percent. Yes?
Without the replacement, so the second one, 12 divided by 21 or 20?
No. With replacement.
Oh, okay.
Now I'm going to do without replacement.
Sorry.
That's all right. So now watch. Without replacement, and I ask you the same questions, right? So obviously it probably is going to be independent. It's still 2 out of 21. But now I let them leave. Out of the haunted house, I let them go. I don't put them back in, right? So now what's probably the next one's going to be a Republican, like you said. What's it going to be? 12 out of 20, because I lost one person. They escaped. And whatever the hell that is.
5.7%.
No? Okay. And then 2 Democrats. Well, the first one being a Democrat, 7 out of 21, and then we let them run away.
6 out of 20.
And then 6 out of 20. I like it.
10%.
10%, yes, good. I like it. So you can see this probably went down a little bit because I have less chances to get a Democrat on the second one, but this probably went up a little bit because I still had all the Republicans on the next one, blah, blah, blah. Maybe. Maybe not. All right. So now everybody's waiting for number 3.
Yeah.
So here's a really beautiful thing about large populations. And help me out a little bit. Why do you think it'd be wrong if somebody, and I'm not picking on me because somebody suggested this, and I understand why you did, but why is this wrong if I start this problem like this? And let's Talk about the right way to start this problem. Just like up here, I put 2 little spots because I was picking 2 cards. How many spots do I put now? Because I'm picking 4 people, right? So, this person and this person and this person and this person. They're all going to have certain opinions. But what's wrong if I start doing this? What is this number supposed to represent?
Percentage.
No. 9 is supposed to represent the total. So you're saying that there are 100 people in America. 1,000 America. Maybe there are 100 people. I'm just imagining some of you guys. I don't know. But no. So the nice thing is, how many people are in America? Let's say 320 million. Around there. Last time I checked, it's probably 330 million by now, the way people just go at it. So let's see. What is 9? What is 9% of 320 million? Stay with me now. I want to show you something mathematically. I'm about to do some stuff that I never want you to do. And you're like, you're going to turn off now. But I want to explain why you're allowed to do what we can do, which makes this problem so easy. Now I got you back, mate. What is 9% of 320 million?
28 million.
28 point...
Million,
20.8 million? Okay. Alright, now watch. If I really wanted to do this like this, the first person would be 28.8. In fact, let's just do this right. Out of 320 times... Now, to be honest, let me change the problem a little bit because I just want to make this easier. Let's say I want them all to not like North Korea, right? So then this would be times 28,799,999 over 319,999,999. Now the reason we don't have to worry about this is not because we get tired of writing 9. Somebody help me out. What is this divided by this? Do that for me. Somebody. It's a bunch of 9s, right? If you can't read it, it's just 9s. Help me out. What is 28,799,999 divided by? I like the way some of you guys, I'm not going to do that. You're surrounded by these people that are going to do it for you. All right, that's great. I'm not trying to make you feel bad. You're like, I was doing shit earlier. I'm like, all right, that's right. Sorry.
0.899999.
Yes, thank you. As a human, would you say, and it's 0.08, right?
Yeah.
As a human, that's freaking 9%, isn't it?
Yeah.
In fact, if you keep going, then if I do one more person off, it's going to be the same stupid thing. So it changes so little that we just leave them all the same percentage. We don't have to worry about trying to make a fraction if my population is big. Maybe you're with me. So here's what this boils down to then. This is almost too good to believe. Let me bring it back up here. Almost too good to believe. And you're like, I will agree with you when I see it. Let's see. So here's a video. You put your 4 spots. Now the probability somebody is favorable is 0.09. What's probably somebody is not favorable? 0.91. Okay, that's a good thing to know in general. So I want the first person to have a favorable view, right? So what's going to go there? 0.09. And then I want the last 3 to not have a favorable view. So what's going to go in those 3 places? 0.91, 0.91, 0.91. Now real quick, let me just point this out, a little mathematical aside. Isn't that the same thing as 0.09 to the first times 0.91 to the third? You guys remember the idea of exponents, right? So multiply 0.91 3 times, I can just write. So look how this is beautiful. 3 don't, 1 does. Bam! The idea is right there. It's almost too good to believe.
How'd you get 0.91?
So if 9% view that favorably, how many don't? The rest. 9% do, how many don't? 91%. 100% minus 9%. Yeah, that's the idea of complement, right? So what do you get when you multiply this out?
0.0678.
0.0678. Sounds about right. I don't hear anybody saying anything else.
Yes.
That's good? All right, thank you. All right, maybe. So it's the same idea that we were applying up here, but how big was our population up here? 21. So these, let's see, 7 out of 21 is pretty decently different from 6 out of 20. They are changed by a decent amount, so we have to show that. But when a population is large, then we don't have to do all that. We just leave the percentage as it is. Thank God. And I like part B. And here's the neat thing about at least one. Let me see if you guys can get this. Let me turn this over. Now, we've seen stuff like this before. Now, just go with me. Go with me. Let's say I ask, what do you want to say, Jeff? Screw it. Let me just put this down here so you guys get this. Two. All right. So that adds up to 1, right? This is probability of X. So I asked people how many TVs they have in their house. All right, so 10% of people said they have no TVs, right? Because they have smartphones and they have the Netflix app, right? So I was too specific in my question. Too bad for me. 20% have 1 TV, 50% have 2 TVs, 20% have 3 TVs, and then the other people I just didn't talk to. The people that have TVs in their drawers in their bathroom and stuff. Yes, okay. So the probability that somebody had at least 1 TV. Now I can get that probability very quickly because there's not very many things. At least 1 is 1, 2, or 3, right? But of course, now what is 0.2 plus 0.5 plus 0.2? Do you see how this is the same as 1 minus this? Do you understand why that's silly to even just go, well, of course it is, Jeff, because these all add up to be what? 1. So if I wanted probably at least 1, that is equal to 1 minus the probability of none, because they all add up to 100. And so let me write this a little different. What's the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3? What is that? It's 1. Of course it is, right? It's got to be, because that's everything that could happen in this case here, right? You guys with me? So where's at least 1 here? Which things match at least 1? Yeah, these match at least 1. So if I subtract this, I can solve for at least 1, and there you go. At least 1 is always 1 minus the probability of none. So any probability is equal to 1 minus its opposite. And if the opposite has less work, I think I'll do that. That's almost too awesome to believe. I know I've said that several times today, but it's actually true. So what sucks, if you try to do this directly, what does at least 1 mean? This is awesome. It could mean the first one views them favorably and the other 3 don't. Or the second one views them favorably and the other 3 don't. And so maybe the first 2 view them favorably. Or maybe the first one and the last one. Or maybe the last 3. Or maybe the middle 2. Holy shit. Do you guys start to understand? You'd have to take all those situations into account. Because what's probability? It's always about adding in all the ways there is to do something. And how many ways is there to have at least 1? Many. 1. First, second, third, fourth. 2. First 2, middle 2, last 2, first and the last one. Scratch. How many ways is there to have nobody like it? How many ways is there to have nobody? Only 1 way. None of them do. There's only 1 way to do it. So which way has less work? The opposite has less work. So if I do 1 minus, so probably of at least 1, equals 1 minus probability of none. So I want nobody to view North Korea favorably. So what's that going to look like? Let me just calculate that over here. What's probability 0 going to look like? Nobody views them favorably. So each one of these is going to have what?
91.
91. I want this person to not view them, and this person, and this person, and this person. So 0.91 to the 4th power, because I got 4 people doing that. And what is 0.9191? 9191. What is it?
6857.
6857. Kick ass. So then our answer is 1 minus 0.6857.
0.314.
0.3143. I like it. Maybe. So if you wanted to do that problem straight up without doing this idea here, if you just want to calculate this straight up, you would have to do the probability of 1 And there are several things. Let me see if you guys get this. How do you do the probability one? Well, it could be the first one's favorable and the other three are not. Is that cool to use F and N for that? Favorable and not favorable. Or not favorable, favorable, not favorable, not favorable. Or not favorable, not favorable, favorable, not favorable. Or, so see how I keep saying or? That means add the probabilities, right?
Yeah.
So each one of these is probability of that, probability of that. I'd have to calculate each one of those and another one plus 2. Maybe the first 2. Maybe do you start to understand how much work there is there, right? But so that's related to adding this up. That's not a lot of work, but I'm saying, what if this table was really long? That would be kind of a lot of work. Instead, I could just do 1 minus this dude. And mathematically, it's just, of course, they equal each other, because together they make 1. So 1 minus a piece of it will be the rest of it. That only makes sense, is my hope. Okay. I like this last one. What is the formula for given? Well, let's use these. I want to know the probability that they like Brussels sprouts, given that they are favorable for North Korea. So that would be probability of Brussels sprouts given favorable, right? What's the formula say that is? I forgot how to calculate. No. Sorry, don't give me numbers. What's the formula say? Because this one, I have to use a formula. Do I have stuff I can just count? Do I have little people there? No.
It's the probability of Brussels sprouts and North Korea over North Korea.
Yeah, over the given. I got you. Good. So it's the and over the given. That's the formula for given. So I did that because I don't have a situation like the first problem where I can just count stuff. I just have probabilities, percentages. So now what's probability of Brussels sprouts and favorable?
6%.
6%. I tell you that directly, 6%. What's probability of favorable North Korea?
9%.
9%. And what's that? Sweet. See, so that's when the formula comes in handy. When I don't have stuff I can count. On this first problem, I can see everybody. There's everybody. I can just see them. I can just count whoever I want. Here, I don't see anybody with Brussels sprouts in Korea, North Korea. I just love the fact that somebody said probably Brussels sprouts and Korea. That's not a phrase you thought was going to happen to you today. But it did. You're welcome. All right, so like I said, next time I have like a practice quiz you guys can work on over the weekend to get us ready for the quiz.